Okay, so this is the second session. Let us talk more about this. So he is assigning. Can you hear me well?
Yes.
At the ninth index, he is setting the next node to be -1, a null pointer. That, and the same is also done in the pseudocode. I think it is clear to you now.
Yes.
Okay, perfect. So let me see. So would you like me to explain about how to add a node? We should explain it in Visual Basic, or we explain it in pseudocode. There is just a slight difference between what is done in the pseudocode and what is done in the Visual Basic, especially in the naming that he used. So tell me first, what you prefer. Would you prefer that we go through an exam, or would you like me to? I mean, not a complete exam, just an exam question that is talking about linked list, or should I go through first how to add a node in Visual Basic or pseudocode? Let me understand from you what you want.
Could you explain how to add in VB?
You would like to know that, or it's fine?
No, I would like to know that.
Okay, so let me. Is it better? I think it's better because I already have. Let me see here. Let me see. Okay, so here, let me add node. Let me see, add node here. Let me go down to the definition. So, okay. This is the add node function. I think I would like to see how it is called first. Okay. So first, let me just share with you this add node function will take three things. This is let me see here. Sorry. Yeah. Okay. So this is partially the code that you have seen just now about initializing the linked list as a node. And yeah, so this is the initialization. And let us go down. So here we are just entering some data. That's because it was part of the exam requirement, question requirement. And again, let us go to add node. So add node, he's taking here the linked list, array of linked lists that we talked about. He's taking the pointer, and he's taking empty list. But you will see that we taking the three of them by reference, because the three of them need to be adjusted. We need to add something to the linked list, and we need to adjust the start pointer. The start pointer will not be adjusted, but the empty list will be adjusted. Start pointer always point to the first thing, unless what we are adding is going to change where we start. So okay, so this is add node. Let us go again where it is defined. Sorry, this is add node. Okay. So here, yeah, like I told you, the linked list is taken by reference. Here, the current pointer is taken by val, but the empty list pointer, because we're going to add something, so it's taken by reference. Again, it depends on the requirement, but this is, I mean, typically you will change the linked list and you will change the empty list since you are adding something. Okay, so you have to give them by reference here. And let me see here. So here he is asking the user to enter something, and then he's reading it as an integer. the data to add, because the linked list that he created is actually full of integers, not strings. And then he defines something called previous pointer. Okay, so typically he would like to loop through a list, the list here. That's why he always use something called previous pointer. So the current pointer will be pointing. So he will search, and sometimes when he's searching, the current pointer will point to -1, which marks the end of the list. That's why the previous pointer will be the pointer that points to not the last position, not the current one, but the one before the previous one. So let me try to elaborate more. But so empty list, we know that this is a free list, right? So we have a list like that, and we have a free list. So this is, let's assume, yeah, we have this, our start pointer, we have our empty list pointer. So we know very well that our empty list should be starting from either 0 to 9, which is the end of our linked list array, because it's from 0 to 9, right? So if it is bigger than 9,
Yes.
or if it is less than 0, we should return false, because it means that we are not empty anymore. Okay, so if our empty list point is satisfies this condition, we should return false. If not, then we should create a node that is called a new node. This new node is going to have a data and have a next node. So it's a data and a pointer, and it will carry whatever we entered from the console. Whatever data we entered, we will add it here to the data, and the next node will be pointing to -1. Do you understand why it need to point to -1?
Yes. The end of the list.
So tell me why.
It would, because it's not pointing to any other data. It's the last data to be added.
Okay, so it means that we add it to the end of the list, right?
Yes.
Okay, so if you see here the new node that we created, we will put it here in the empty list. So we are checking where our empty list pointer is pointing to in the linked list. So if it is, let's say it's pointing here, so we will put our new node here. Okay, this is our new node, and this is our empty list. And then we will initialize the previous pointer with 0 before we enter our loop. So the purpose of the loop here is to go through our linked list. Let me see here. Okay. Again, what we're seeing here. So this is a while loop. This while loop have 2 pointers. Current pointer, this is, we get it as a parameter input to us, which is the start pointer here. Okay. So we said if it is not -1, then we should do this. We should do the while loop. Okay. So why we don't want to go through it when it is -1? So we do while it is -1, but if it is -1, we will not get
the list.
No. If my start pointer is pointing to -1, it have an indication. Tell me, what is it? The start point is pointing to exactly. Yes, it's empty. So yes, so it is not the end. So if it is start with -1, yes, it can mean that we reached at the end, but it also should not start if we are -1. -1 means there is nothing here. And if you can remember, if you can recall back, let me see here. If you can recall back here, when we started, so can you recall back this? This is, you have to always keep it in your mind. So we always start our start pointer by -1. This is a totally empty list.
Okay.
And the free list always start with 0. This is totally empty, right?
Yes.
Okay, perfect. So we go back. Okay. Am I right here? No, sorry, that's totally wrong. There should be something different. Yep. Okay. So yeah, we are here inside the while loop. While the current pointer not equal -1, then what should we do? We should put the current pointer into previous pointer. We should do this assignment. Typically, we started with previous pointer, which is 0. So if we have anything here, so imagine that we said we have L here. Let's say from the example that we saw, we have B, and then we have D, something like that. So we start with 0, 1, and let's say 2. So we started with B at the first. So let's say if the current pointer is 1, we put it as the previous. So previous now having not 0 anymore, it have 1. And then we give a new value to the current pointer. So we said, go to this pointer, this element here, go and bring its next node and assign it to the next pointer. So actually what we are, do you understand now what we're trying to do here?
Yes.
We are trying to traverse through the linked list. So we go one by one through the linked list until we reach its end. So we have to add to the end, right? So since we want to add, we want to reach the end of it, which is -1 by the current pointer. So we will keep looping around until we reach the end. So typically L point to -1 because this is the end. So once we reach -1, it means that the current pointer reached the end. Can you still remember? We have an array like that carrying -1. You still remember, right?
Yes.
Okay, perfect.
Yes.
So if we reach the current pointer -1, then we don't know yet where is the place to add. So that's why when we reach -1, it means that the pointer earlier we should be adding to it, which is previous pointer. So he will take previous pointer here. So let's assume B is pointing to D, so it will point here to 2, and D point to 0, so here 0. So if the current pointer reaches to be -1, it means that the one before it should be 0. So the previous pointer, it should be pointing to 0, okay? And then we should start to add here before we reach the last one. So again, a linked list here. We should okay, the empty list. Let's say our empty list here. Let's say assume that we want to put F, for example. Okay, and we assume that empty list here equals 3. Okay, because that's the first empty list, the first place. So he said put the empty list pointer, which is 3, to value to right. And then he asked us to go to the previous pointer, which is pointing to 0 at the moment. And then he put 3 there. Does this make sense?
Yes.
Okay. And then the empty list now should not be pointing to 3 anymore. It should have something different. It should be, so previously this empty list was pointing from 3, it was pointing to 4. So we should say that in the empty list now should not be pointing to 3 anymore, it should be pointing to 4. To what was the previous position pointing to. So here should be 4, and we should return true. So that is the process of adding. Okay. So let me see. Let me confirm this again. Previous pointer pointing to 3. Value to right, and then these 3, they should be pointing to 3. Pop, pop, pop. 0 should be pointing. Previous at 0 should be pointing to 3. Yeah. And if you can remember, so the next node, the f that we created, should be pointing to -1 automatically, because that's what we added at the start. Yeah. So that's basically, if you have anything here, just let me know.
No, it's clear.
Okay, good. So let me see here. Let me share with you one more thing. So once we output something here in the, let me see, in the code. Okay, so let me go back so that we don't waste more time. We talked about adding, inserting into the VB find node. Would you like me to explain to you how to find a node? So it means that we provide the data and we return the pointer. Is that clear to you, or I go through it?
Oh, no, it's clear.
It's clear. Okay, so okay, this is an exam questions, but let me try to go through, because again, you told me that you don't want to cross more than an hour. So I would say, let me give you an introduction first to the binary tree, and then maybe if we have a time or chance, then we can go through the exam questions.
I understand how to create a binary tree. Could you go through one of its what do you call it? The traversal?
No, just can you repeat again, because your words was not so clear?
Okay. No, I understand how to create a binary tree. Could we go through one of the the traversals?
Okay, for the binary tree, right?
Pre-order. Yes.
Okay. So, okay. Let me see here. So do you understand how to add something to the binary tree or no?
I do.
You do. Okay. So do you understand what is the benefit of having a binary tree?
No.
Okay. So did you I see I already passed you one of the questions with a binary search. Do you know the difference between a binary search and a linear search?
Linear search checks each individual data in order, and binary search checks from the middle. It finds the middle value and checks both sides.
Yes, somehow.
And keeps doing that till it finds value.
Perfect. Okay. So if which one is more faster, the binary search or the linear search?
Binary search.
Perfect, because it doesn't have to go through all the array, right? Or even
Yes.
Perfect. And that's a good thing. So it means that we are able to move faster when we are doing the binary search. So the same applies. So the why actually we make something called linked list, and even why we make a binary tree, and let me say it in another way, that why we make even a hash table, all this kind of hashing and complications. Why? When we are having a lot of records, 1,000 or million records, and we want to search through them, we want a way to reach to search all of them very fast in a little amount of time. So in a binary tree, things are organized similar way, like the binary search order thing. So he is able to reach his what he's searching for very fast because things are ordered. We always find on the left branch values that is lower than the right branch. Is that correct or no? Okay, so it means that it somehow can save us time when we are searching a long list, maybe 1,000 of items. Then this can help us when we follow this kind of algorithm. So I said you already know how to add things, so you just want to go through. Um, okay, let me go through traversal. First, traversal, actually, you can, there is many concepts here that he sometimes asks in the exam. So first, there is something called in order. I will show it to you. And another one called pre-order. Did you come through both of them before?
Yes.
Pre-order and in order.
Yes.
Perfect, perfect. And you want to go through searching through an array. So you're talking about searching or just looping through the tree node?
Searching.
Searching. So it means that you would like to find node here. So you would like to go through it in VB or tree node. Let me see if we have something even with a tree node. With a, let's go through it first here. So it means that we try to find a node. We try to find, as we have an item to search, and we would like to return an integer, a pointer to that node. So we have a while loop that will go through everything until we reach a null pointer. He say, and this is a free node, and which is a root pointer of the tree. So we have a tree, and we have right and left here, right? So if this node pointer does not point to null, then we should go through here. So again, the question now is, we would like to return a pointer, right? Where we find our item.
Yes.
So he's giving here two conditions. As long as we didn't, our root pointer is not equal null, it means that it's not empty first, and that the current pointer data does not match our search item. Then we should continue searching. So what he do here is just a simple comparison. He is taking the tree, the array of nodes, and he's comparing it. It is bigger or smaller than this current data. So let's assume here is 10, and assume here is 9, and here is 11. So it means that if our current pointer here, the data we are trying to search, for example, it is 9. So if what we are pointing to here bigger than the search item, so it means that we let me see. This is 9. If here is 10, if it is bigger, what this means? So it means that we follow the left pointer. Let me check this. I believe this is something is strange. When we search the root pointer here, if it is bigger than the search item, it should go to the right.
So it works the same way as binary search.
Yes, yes. If it is bigger, so it is if it is here, if it is 10 and bigger than 9, we should go to the right, not to the left. It's quite strange. That's quite strange.
It's on the left side, right? If it's bigger than the search and we're trying to find the search, we should go to the left.
Yes, if so. So do you agree that this is slightly strange? It should, or
I think it's correct
correct.
because if it is bigger than the search item and we're trying to go to the search item will be on the left side.
Okay.
So we'll go to the left pointer.
If 10 bigger than 9, then we should go to the left. Yes, correct. Yeah, I agree with you. Yeah, slightly I was confused. So yes, so this is a node pointer that we should have. So it means that we should reassign the node pointer that we have here to the one in the left. We should get the pointer to the left here, and then we should repeat the while again, and then we should check the item we are searching if it is equal. If it is not equal, the search item in this case, it will be equal. So it will exit the while loop, and then it will return whatever pointer that we find here. Of course, if you have more items here, then it should be always going, getting whatever pointer and then rechecking it in the while loop. Does this make sense so far? So let me check here.
Is this the other one you were talking about?
Sorry, again?
You said searching and looping through. What does the looping through mean?
No, I would like to hear your question again. Sorry, I didn't get it.
Okay. No. Before you asked me if I wanted to understand the searching through a binary tree or looping through a binary tree. What do you mean by looping through?
So looping through it. So when you traverse it, it means that you just go and print the value inside the tree node, the binary tree. So finding just you search for some item and you return a pointer to that item that you are searching for. But when you are just looping, you just go and print all the items inside. Let me just share with you what I meant by that. It's just like you say print all, but again he have let me see here if I do it, find node. I believe it might not be here, but let me share with you that I believe the code is shared. No, it's so yeah, this is a linked list. Yeah, for the binary tree here, actually one of the things that yeah, so what I mentioned now is if you want to print whatever in the array node or even the binary tree, and there is something called in order that that is also going. So this is just showing things in a specific order inside inside the binary tree. So let me show you the print all. This is looping through the binary tree. So okay. So again, we just have 10 minutes. You want me to continue like that? I think because we are crossing over 1 hour. So we have 9 minutes. It's enough for you, right? or we need to close and open again?
I think manual.
Okay, perfect. So print all, it will just typically go through our 2D array. No, let me first introduce you here. So binary tree, in one of the exam questions, it's built using a 2D array. Okay, and the 2D array was somehow, let me share with you so that okay, so let me go through here. Let's see here. So again, he asked us in the exam question that we create a 2D array, and this 2D array have 3 columns: left pointer data and right pointer. Okay, and the data is always in the middle. So that is what was implemented here in the code. I think you can see with me now. So this is the array nodes. I created constants, one called L pointer and one called right pointer. This is just to avoid confusion when we're talking about the exact position where we should be looking into inside the 2D array. So these two positions, is the left pointer and the right pointer, and the data should be always in the middle. Without these two, you will be slightly confused if you want to write any code, especially when you are trying to add or even delete from the array node. So okay, we initialized that 2D array, and then if we want to loop through all the data here, so we created a for loop. We pass the array nodes by reference, okay, and or even by value. It doesn't matter because we're just printing it. We get the upper bound, what we want to loop through, and then we just print here. If you can look around here, so I created here. We go through every row in the 2D array, and we just print the 3 items here: the left pointer, the data, and the right pointer. So that is, you can just simply see here. This is just an example of what we can print. I mean, we are looping through all the array, the binary tree, or the array of nodes. So this is the left pointer. This is the item. We enter 10, 11, 12, and 13. This is all the items inside the binary tree. And that is what is right pointers that we have. And so, yeah, and what we have here in the left pointers is -1. And you know that what we need to do to initialize a 2D array, I think it's similar here. When we initialize a binary tree, we need to put all the free items before we touch the array nodes and before we enter any data inside. We need to do similar to the linked list. We need to put all the free places here, right, on the left pointer, right? Okay, so the in order that I told you about that comes in the exam, I think you saw it before. Let me see. Okay, let me search for it. So did you see that before? This code before?
No.
Yes or no?
No.
So that code actually use a recursive call, and it will show the data in so it will just print the data in a specific order. That specific order is, and that's why I asked you here about this. Let me see here. So in order traversal will print the data in so it will visit the left subtree, and then the current node, then finally the right subtree. It means that it will go first on the left branch, finish it, and then it will go to this current node, and then it will print whatever on the right subtree. So it will go to the left current and then right. Pre-order is different. It will go to the current node first, which is this one, and then finish the left subtree, and then the right subtree. So this and this, I have seen them in the exam, and the implementation of this in order is like that. So here, the difference, you see, we have two if statements, okay? We start with the left side first, and then this is printing the current node. This is the one in the middle, and then this is the one on the right side. So as you see, this is a 2D array, and we pass it the current pointer. And if the current pointer is not -1, then it will go make a recursive call. It will keep calling itself again and again until it reaches the end, -1. There is nothing, it's not pointing to anything anymore. So actually, this is the output of this kind of in order. Let me see if we can run that. I'm not very sure if we have enough time, but maybe I try it next time with you. But again, so we keep calling here recursively until we reach -1, and then we go and print the current node, the one in the middle, and then we go here, print all the things on the right branch until we finish it all, also recursively. Does this make sense so far?
Yes.
Okay, so now before our time runs out, just let me know, what do you need to know next time?
Could I message you?
Searching?
No, could I message you?
Yes, you can. And
Okay.
let me understand from you first. Would you like to have would you like to go through some exam questions for the linked list and binary tree, or no?
You send me them as homework.
Okay, yes, I can do that. Yes.
Also, my exams are starting soon, so this next week. So is it possible if I could message you like 2 days before, 3 days before our next class?
Yes, you can do that. Yes.
Okay.
But you have to.
I don't know if this Thursday I can have class.
Okay, no problem.
Next week I have continuous exams.
Okay, no problem. So when is your exam for the paper 4?
It's at the end. I think it's on October 31st.
After 31st